In this video, I want to look a little bit more at the for all quantifier. Sometimes that's called the universal quantifier. So, to avoid having to explicitly write out every component in a conjunction, we might use the universal quantifier, or for all. For example, if we wanted to write out the predicate that is described by P of 1 and P of 2 and so on, P of n minus 1, to write it in quantification form, we might say for all k, where k ranges from 1 to n, not including n, of pk. In general, we could express the predicate as for all k in the range of rk, P of k holds or is true. So, this is the universal quantifier. Some things to note about it. We read it as for all, and k in this case is my variable. It's bound. It's a bound variable, which means it only exists. Its scope is between the parentheses of my expression. And it's read as for all. Notice I could easily change, instead of using the variable k, I could have used the variable I, j, whatever we wanted in here. So sometimes I think of it as a dummy variable. And again, its scope is only within the parentheses that describe the quantification. R of k is also a predicate that specifies the range of the quantifier. That is, the values for k that make this predicate true are the range. And P of k is a function of that, is a predicate itself that's a function of k. Let's look at an example of when we might use this universal quantification. So sometimes what I like to do is to translate English specifications into symbolic forms. Now, in this particular example, what I want to do is translate predicates with universal quantifiers, and you'll also get an idea of the notation we're going to be using in this course for arrays. I think it's the notation from MATLAB. So let's say that our instructions are to write the following in predicate form, which actually means to write it in symbolic form. I've seen examples of exercises like this where the instructions are formalize the program specification, which again means to write it in symbolic form. Let's say what we want to write in symbolic form is that all elements in a subarray, where the subarray notation is j through k, are 0. Okay, so this is the notation MATLAB uses for subarrays, which means that it is the part of the original array where the indexing ranges from j to k. So all elements in the subarray are 0, which means for all. Now I need a variable to use here. I don't want to use j or k because they've already been used in my description of the subarray, so I need to pick another one. Well, I could pick m, n, p, whatever. I'm going to use I, though. For all I, well, what's the range of I? I is between j and k, including k, or I could say less than k plus 1, because again, remember, this range is describing all integer values that are between and including j and k. And what is the expression I want to hold, the predicate that must hold? Well, the entries, and the way we, in MATLAB, the entries, the ith entry is described, is by b, and in parentheses I, is equal to 0. And that's it. So Anytime we have an expression where we want to describe all elements satisfying certain conditions, we're going to use the quantifier for all, or universal quantifier. Next videos, we'll look at there exist quantification.